Welcome to another video on smart architectural programming. In today's video, we're going to go over another Blind 75 problem. In particular, we'll be going over the remove node from end of linked list problem. Now, this might seem quite simple. Just from the title, you might think that we just need to remove the last node of this particular problem and we should be good. But there's a caveat to this problem that we need to understand. So to start off, let's move to the whiteboard because we're going to solve this problem on the whiteboard first. Let's use, so we have basically presumably a linked list, and just as a quick recap here, linked lists basically have nodes which have the individual values, and each of these nodes basically are connected in a one-way linkage with another node. Basically, as you can see, the arrows are the linkages and the numbers are the nodes basically. So that is what a linked list is. So given that, we need to remove an element from this linked list at the end and do so in an efficient manner. So would we go about doing that? So let's digress a little bit from the solution and focus on basically how or what we need to do. So potentially, give me a second. So potentially, what needs to happen is that this particular linked list needs to be dealt with in such a manner that the output of this linked list looks something like this: 1 linked to 2, linked to 3, linked to 5. So what is the difference between these two linked lists? The bottom one in purple is the output that we want, and the one in black is the initial input that we get. So basically what we need to do in this particular problem is that we need to identify the second last element of the linked list, which is 4 over here, and remove this from this list. Now this is quite tricky basically, because in linked lists we have no idea how long a linked list could be, right? So if we don't understand how long a linked list is, how would we identify exactly how we can solve this particular problem? So to do that, basically, we would first, we could potentially, what we could do is reverse a linked list, right? Cut these connections out and reverse the direction of these linkages. And reversing a linked list is something that we've already covered previously in our previous videos, so I won't go over that again. So potentially, if we cut these values out, right, like this, we could potentially select, just find the second element of the list and do that. But this is a very, very inefficient way of solving this problem. What does that mean? That means that we can't use this particular problem, solution to this problem. So we need a better way to do that. So presumably, you need to remember that at the end of a linked list, the last element of a linked list, let me change the color over here, also points outside, but it points to the null element basically, which tells us a linked list has ended basically, right? So based on that understanding that a linked list ends at null value, right, we need to basically after that we need to solve, based on that understanding, we can solve this problem easily. But to do that, we can't just use any simple method that we use in other data types. We're going to use the slow and fast pointer method to do that. So let me change the color here so we can use those pointer methods to solve this particular problem. So let's use a green color here, right? So a slow pointer, we have two pointers, a slow and a fast pointer. At all times, what you'll need to remember is that the difference between the slow and fast pointer is 2 in this particular case, right? So, sorry, not 3, 2. 2 is the difference between the slow and fast pointer. So after every step, basically, we move slow and fast pointer one step ahead. It comes to 2, this comes to 4, we cut this comes to 3, slow pointer comes to 3, while fast comes to 5. We cut this. When fast points to the null value, that's when we understand the linked list ends, right? Similarly, while fast is pointing here, we also see the slow at that point is pointing to 4, which is the second last element. So we can identify what the second last element is. But the issue with linked lists is we can't just simply, say that, the fast and we can remove 4. We need to remove 4 by cutting the linkage between 3 and 4 and then connecting pointer 3 to 5. But the issue is we're not pointing to pointer 3 over here, pointing to pointer 4. So we can't do that. So to do that, we use another method here. Let's remove these values over here. So we can actually redo this. So let me use another color here. Let's use red again. So before, at the start of every pointer, we'll create another variable value, which is dummy. The dummy value, it would help us not only handle this problem, but it would also help us handle other edge cases. The dummy value is pointed towards the first value of the linked list, right? And our slow pointer is pointed at the dummy value. The fast pointer is still pointed at number 3. So the distance between the slow and fast pointer has become 3. So as we move to the end, let me correct 3 properly here. So as we move forward, ultimately the fast pointer, when it points to null here, right, our dummy variable would be, our slow variable would be pointing to 3 over here, right? Which means we can cut this linkage and can cut it directly to number 5. So that is how you can potentially solve this particular problem in this problem. So the logical solution to this problem is as such. Now, given that our logical solution is as such, how do we solve this problem? How do we code this out? Let's focus on the coding part next. So let's start coding. So first, basically, the first thing we need to do is create the dummy variable, right? The dummy node. So we're going to do that using our, let's type this out. Dummy node creation. And to create that, basically, we create a dummy variable and use the constructor method to create that. So list node 0. That's how we create our dummy node here. Next, we need to start focusing on pointing our variable to the dummy's head. So we do dummy.next, which points towards our head variable, head of our list, basically. So dummy is now connected to our list and is pointing to the head of the list. Then we need to start up initiate the slow and fast pointers. Both of them at the start will be pointing towards the dummy variable. So let's do that. Once that's done, let's move on to the next thing that we need to code out, which is we need to move the faster pointer first, and move the slow pointer slower, basically. So let's set that up. First, we're going to basically write a for loop within the range of our node and move the fast pointer based on that. So let's write that out. So our for loop is set up. The next thing we need to do here is move the fast pointer. Alright, now that we've moved the fast pointer, the next thing we need to code out is the slow pointer. So while fast pointer it does not point to null, we need to move the slow pointer. So we'll do that. Now that we have sorted the slow pointer as well, we remove the nth node basically while we're moving the slow node. So we need to do that next. sorted that. Next, we need to basically return the head of the list. So we're just going to return dummy.next. So if we run this code, we should saw all of our test cases should clear. Yep, both test cases cleared. I'm going to submit this code. Our code was accepted, and that is how you solve the simple problem of removing node, second last node from a linked list without reversing it and in the most optimum manner. Keep in mind this particular problem, if we look at the time and memory complexity of this problem, it is O of n, which is the best possible solution for this particular problem, which is something that would be easily be acceptable in a coding interview. So with that, we're going to wrap this video up. If you got any value from this video, please like and subscribe, and also let us know in the comments if there's any problem, any solution, or any issue that you want us to make our video on next. So with that, I'm going to sign off, and we'll see you in our next video. Thank you.